cloud. It is what it is. So a couple things I want to make note of. First and foremost, this is our fourth lecture. Today is the 26th of August. You'll notice that homework 2 has been posted. We will talk about that briefly, or shortly. We're going to actually spend a fair amount of time on it with you. I have not posted any of your quote-unquote quizzes yet, so don't. So I think the due date for that homework, I don't remember what I made it. So it's due September 2nd, so next Wednesday. So we're going to talk about those problems in a minute, but we need to catch up to where they're at. So last class ended. By the way, does anybody have any questions about anything, comments, concerns? So last class we discussed sort of two ways to what we like to say measure data. The first was mean, and the second was mode. Or no, it wasn't. No, what did we do? Median, yeah. What am I saying? Sorry. So these are very simple concepts, and there's some more sophisticated ones which we'll talk about briefly. But the first thing that you should be able to do, at minimum, and you can take from this what you will, but at minimum, so what you should be able to do is you should be able to compute these by hand and, more importantly, using software. What software you use, I don't care. But if I give you 30 pieces of data, you probably don't want to compute the mean and the median by hand. You want to add 30 things up and divide by 30? Probably not. Even using a calculator, that can be tedious. Now, if I give you 8 numbers, that's one thing, but you don't want to do it with 30, 40, 50. You might be one day, you might have a job, and you might have a cool job in analyzing data, and you might have to find the mean of, say, 1,000 data points. You ain't doing that by hand. So what you need to learn how to do, and I am more than happy to help you, but there's lots of videos out there. We'll do it. I showed you how I used a piece of software last class called Octave, but look, you guys are graduating in 2020. Many of you will get a job in a few years, and you will spend a lot of your day looking at spreadsheets on Excel. So if you don't know Excel right now, you might as well learn it. It ain't hard. And anything you want to do in Excel that you don't know how to do, you go to the Google machine and you say, how do I do blah in Excel? And then 30 YouTube videos will pop up where a bunch of really good people at explaining show you how to do what you want to do in Excel. One of the most important skills you should have when you go to potential employers one day is you have to convince them that you are capable of learning. I mean, part of convincing them is that you went away to school and you got a degree in something, but you have to show them that you're capable of doing things on your own, learning on your own. Instead of going to someone with a problem, solve that problem and then show them how you solved it. These are things that most people at your age don't have. Most of you go to your boss and say, or your teacher, I don't know how to do this, or we have a problem. You know what? No boss wants to hear that. Boss wants to know either they never want to know there was a problem because you fixed it, or they want to know that there is one and here's how you're going to fix it. Come with solutions, not problems. And so the reason I'm emphasizing this is because there's only so much we can do in like 3 hours a week with each other. A lot of this stuff you got to do on your own, and you got to learn how to use your resources. That being said, that being said, let's move on. Does anybody have a question or a comment? Good. All right, so let's talk about two other basic statistics. Or as I like to call them, measures, are the mode and the mid-range. So the mode is the number that appears the most. More specifically, we could say most often. Then what's the mid-range? Well, the mid-range is the average of the lowest or the smallest and largest values. So why am I putting those words in quotations? Well, smallest is context. Right? Sometimes we as humans have a hard time thinking about like negative numbers and what it means to be small in terms of the English word and the mathematics word. There's different ways you can discuss and quantify small. Some of us might think about small as being like close to 0. Others might say that -5 is smaller than 26, right? So you have to be careful with how you do this. The mid-range is really a very intuitive thing. You take the number that's the lowest and you take the number that's the highest. So, maybe you put, let's be very clear with what we mean by that. So if we write our data in, say, ascending order, X1, X2. So what do we mean by ascending order? Let's be very clear. That means that X sub 1 is less than or equal to X sub 2, less than or equal to X sub 3, etc. All the way up to, remember, we're at some value X sub n. Then the mid-range is X sub 1 plus X sub n all over 2. Does anybody have a question about these things? Again, you can do all these by hand, but you should become familiar with software like Excel, which I believe you all get for free if you go on any computer on campus. I want to even say now most smartphones have a spreadsheet on them, right? I know Apple does. So, I mean, I don't recommend you doing it on there, but there's lots of software. A lot of it is free. There's web pages that do all this stuff for you. Find one that you like to do that you can use to compute things like these values. And then here's the thing. Some of you will require lots of practice to get to get good at this. Some of you already know how to do this kind of stuff. Every one of us works at a different pace. We all learn at a different pace. What I would highly encourage you to do is figure out what your pace is. And there's no such thing. I don't mean that in the sense that you have to be fast. I don't mean that you have to be able to get it done quicker than everybody else. Nobody likes people who get things done fast if they don't do them properly. It's okay to take your time and go slow. That's completely fine. Does anybody have a question? All right, so before we do an example, we need to make one more definition that is of sort of a great sort of way of doing things. Lost my color. Get out of here. Okay. A useful but less intuitive measure is the variance. So what this attempts to measure how the data spreads from the mean. So if you're unsure what I mean by that, what you need to do is look at the very last slide that we did on Monday, where I said there's two real world scenarios here. We can look at heights of humans, and we notice that the distribution of heights of humans has one shape, and the mean is in the middle. Whereas if we look at the distribution of wealth, that is not the case. The mean is nowhere near the middle, and the distribution is completely different. And so what the variance does is it attempts to capture those things. It attempts to quantify how we move around the mean. In particular, how is the data? If you look and visualize data near the mean, how is it spread? Is it really wide, or is it really close to the mean? And the only way you really get a feel for what I'm even saying is by actually doing experiments yourself, computing these things and looking at them, visualizing. So that's what part of homework 2 is about, trying to get you to understand that. So what is the variance? Well, this is scary. It's very, very scary. There's two types. So the first one is the population. Variance. So it's denoted a certain way. It's denoted with the Greek letter sigma squared. There's a reason for this. And what it is it's equal to, you take your data points. So you have x of 1 minus mu. Remember what mu is. That's our population mean. You square it. Then you take x sub 2 minus mu. That is, again, your population mean. And you do this for all your data. Now remember, when we did our population data, we said that there was capital N values in there. I believe so. Was that it? Capital N? And then you take all this and you divide it by how many there are. So remember, there is a shorthand way of doing this, which will scare the heck out of everybody. You might say the sum k goes from 1 to n of x sub k minus mu all over n. So let's remind you of that some of these things are. So mu is the population mean. X sub 1, x sub 2 are the data. And capital N is the population size. So there's a lot of curiosities about this for students. I know I had one. You might say, well, let's think before we do anything else what this formula is kind of, what's measuring. Let's look at it. So what I'd like you to do is I'd like you to look at the top line here. Look, just pick one of the things that has parentheses. What do you see inside? You have a data minus mu. So what that measures right there is it measures how far is that data point from the mean. That's what it's doing. How do I tell how far apart two numbers are? I subtract one from the other. That tells me how far apart they are. You learned that in like 5th grade when you learned the number line. So the question you might have then is, why are you squaring it? Why don't you just add up all their distances from the mean and then take that average? Well, that can lead to some very, unfortunate circumstances, because what if some of these numbers are duplicates? Then they would cancel each other out. So what we found a long time ago when we're doing science is it's often more useful to take your distance squared. So there's a fancy name for this. This is called mean squared distance. And it's used all the time. Some of you may have seen this if you in chemistry class or biology. Did you ever do like a linear regression before on a computer where you fit a line to data points? Has anybody ever done that? You have no idea how it works. You just plug them into a computer and it does it for you, right? Yeah. The way it works is quite complicated though. That's why they don't tell you how it works. You need to know calculus 3. You have to know a lot more math, but at least we make sense. If I have a bunch of data points, I might try to find a best fit line, is what they call it. And what you're really doing to get that best fit line is you're using this mean squared distance. So that square is there because what it does is it takes any chance of things canceling out and gets rid of it. So it doesn't give you any mistakes. It is a good description of the data. Does anybody have a question about this? Now, as you would imagine, this requires a lot of computation. First, if you want to do this, you need to know what mu is, right? So that means you'd have to find the population mean first. Now, if you have a lot of data points, that's hard to do. And then you would have to find each one of these values. Say you had 100 data points or 10,000, that's a lot of work. Turns out that not only the computers can help with this, there's other formulas that we'll learn about in the meantime. Okay. Very good. All right, now, we also had before, we had population mean, but we also had sample mean. So that means we also would expect there to be a sample variance. So it's very similar, only we're not going to call it, what we usually do is we don't call it sigma squared, we call it S squared to distinguish it. And the formula is nearly identical only it has one subtlety. So let's first write out what it is. Remember, our sample mean is X bar. And so remember, we only went out to lowercase n here. And the one subtlety is we're not going to divide by n. We actually divide by n minus 1. And I'll explain that in a second. So that's something that usually throws sort of confuses the students. So if we wanted to write this using summation notation, it would be this. So what do these values mean again? Well, remember, X bar is the sample mean. Of course, X1, X2, all the way out to X sub n are the data. And then n equals the sample size. So I can't emphasize this enough. Note, we divide by n minus 1, not n. And so that is a curious thing that most of us, and so this deserves a little explanation right now. So why would we divide by n minus 1 and not n? Well, what we need to do is we need to go back to our original example from last week where I said we're going to determine average heights. Right? So before we do that, does anybody want to ask a question? Say anything? Tell us what your plans are for tonight. Anything fun? Sit in quarantine? I don't know, man. I've seen everybody getting it in. The whole world's mad at you college kids because they say you're going to ruin it for everybody else. I like how people are shocked that you're not listening. Like anybody listens when they're 19, right? No one did. Oh, the good old days. There was actually an interesting article I read today where there's been some recent research that suggests how it's transmitted, and it would actually be very good at explaining how these spikes are happening and where they're happening. So that's promising. We'll see. I don't want to wear a mask anymore. I'm over it. But we have to respect the authorities. Okay, so why divide by n minus 1? So let's go to our example from last class where we want to know the average height of adults. And we said there's no way that we can do that. There's no way we could take every adult on this planet and we could determine their height in any reasonable way. That'd be way too difficult. So instead we say, okay, we're going to sample that population. All right. So then what happens then automatically, we know that when we sampled it with 10,000 people, we know automatically that mean we get, that sample mean, is only an approximation of the actual mean. Do we get that? So that's why we call that sample mean a statistic, and that's why we call the population mean a parameter. Because we can compute the sample mean, but we might not necessarily be able to compute the population mean, even though we know it's theoretically out there. If some alien forms came down and they were super smarter than us, they could figure out our average heights instantaneously, maybe. I don't know. Right? But we can't. So we sample it. So that means our sample mean is not necessarily the correct mean. So then what we ask ourselves is how close is our sample mean to the theoretical actual mean? Does that make sense? Now, as I mentioned last class, this is a whole other branch of math. Estimation theory, parameter estimation. It's a big deal in statistics. And so what we're looking for are what we call estimators. We're estimating the mean now. Similarly, if we know our sample mean is only an estimation, that means our sample variance is only an estimation. And it turns out that oftentimes if we were to divide by n, we get what we call a biased estimator. That means it doesn't give us, the information we're given is sort of biased. It's not indicative of what we see because it's affected by something. Now, believe it or not, if you were like a math major or a statistics major and you went and studied upper level math and stats classes, you would study these things called the law of large numbers and the central limit theorem and these big scary things. And these big scary theorems tell us that the correct thing to do is to not divide by n, but to divide by n minus 1. Now that's a good thing. It's always good when the theory matches practice. So practice tells us use n minus 1. Theory tells us it's n minus 1. That's good. It's not always the case that theory and practice agree, but it does here. Now, I know that's not the best explanation, but if you want the in-depth explanation of why that's n minus 1, you got to take higher level classes. Or you can trust me with the motivation and the intuition of we're trying to estimate. Remember, the goal of the sample variance is to estimate the actual population variance. Do we understand that maybe? Sort of? You can all nod your head, yeah, Megan. You're like, what is he saying? What is that man saying? I wore a colored shirt for you guys today, by the way. No appreciation for that. I didn't see it. Trying to be professional here. I'm pitching woo, as the kids say. Yeah, in a figurative manner. Remember, I've always told you a class is like a relationship, right? Yeah. I'm not lying to you guys. You got to play the game. Be fair.
Not gonna lie, I was kind of hoping for another Wu-Tang or Air Jordan shirt.
Wu-Tang. You know what? I'm getting a new mask. It's gonna have the Wu-Tang on. Don't worry. Yeah. We'll definitely have some Wu-Tang. That's another thing I'm saying. There's no Wu-Tang in the top 30 playlist on Spotify for all you young kids and your crazy ass music. Just a bunch of like weird kids singing about taking pills and then they want me to feel bad because the one kid, well, he lived up to his mantra. Popping pills, man. I don't get it. When I was growing up, the rappers talked about selling drugs. Now you all want to be on drugs. What sense does that make, right? No, I'm serious about it because I've said this story before. You've probably heard this before. Like I used to argue with my dad when my dad would say, why do you listen to that crap? It's cussing and it's treating ladies with disrespect. And I said, all right, I get that. But there's also some messages. Like I always took some of these messages. Like I didn't learn a damn thing from Shakespeare. But when Tupac said he's out before the other guy, that's the way to profit every time. That was a good message. Work harder than everybody else, right? Get up earlier, do it, right? When dudes are talking about driving around $100,000 cars and stuff, I said, damn, maybe I'll work hard so I can have a nice car. What's wrong with that, man? And if I like the way I look at my nice car with my music and my windows down and the sunroof open, then that's what I'm going to do. Now, other people are like, I want a pickup truck. Well, have your pickup truck. I want my tires clean and I want a nice shiny car with a loud ass Bose stereo sound system. And that's what I did. My dad used to get so mad. Yeah. There's this group called the Ghetto Boys. You should Spotify them once. Rap group, they're famous for years. They had an album. I went and bought it. Back in the day, you had to go to the store. I bought this tape. Now, there are some songs on it. I can't even say the names. And it's a fifth grader. I didn't know what they meant, but I liked them. Right? Well, my dad found it, and as he always did, he found my Guns N' Roses tape, my Ghetto Boys, my NWA, all this, and he would confiscate them. Well, he couldn't believe that they sold this to a fifth grader. Back then, they just sell you anything. There was no rules back in 1990. This is before, like, parental advisory was on things. Although that's not even there anymore anyhow, is it? They just let you listen to everything on Spotify. Like 8-year-olds at home, like, swinging WAP. So... yeah, don't think I didn't hear that one. Amy's like, what is this? Lydia goes, what does that mean? I was like, oh my God, my daughter's 5. Google that one. Amy goes, would any girl talk like that? I said, I guess so, at least 3 of them. There's 3 of them, right? Yeah, anyhow, that's way off topic. But nonetheless, how did we get here? Oh, music. I'm serious. Out before the other guy. That's the way to profit every time. That's stuck with me. I used to pick theme music before my test in college. Like, I'm going to listen to this album over and over again while I study. And then we'd make like these. Back then, when I was in college, that's right when you could burn a CD for the first time. That was a big deal. It took like an hour to burn. Boy, we would have playlists. We'd go on Napster. Because that's when you could do Napster. You could get anything you wanted for like 2 years. And then the government shut it down. Anyhow, find some theme music. Little Durk in there. Little Durk. Oh, Lord. Oh, that's right. Rest in peace, LimeWire. The problem with LimeWire was every time you thought you'd download one thing, it gave you something else. It was the most corrupt system of all time. It had more viruses than anything. And then they figured it out with the torrents. The torrents was awesome. It was all going good till you guys messed it up and put all the hard drives and overrid the servers because you downloaded every movie you could. Way to go, Generation U. You couldn't just download a few. You download everything, even though it would be humanly impossible to ever watch it all. But you did. Amazing. All right. So let's get into the fun of, let's actually put this stuff. Oh, by the way, before we do that, we should say one thing. The square roots are called the standard deviation. So that's why we use that square on the sigma squared. So sigma and S are standard deviation. And of course, they have that adjective in front, whether it's population or sample. Cool? Good. You'll mess it up. That's okay. I did too. As I said, there's some shortcuts to this, but, you know, for the most part, I don't really care that you, I should point this out. I don't care if you do this stuff by hand, because really in the real world, no one's doing it by hand, but you should suffer. Let me make this clear about homework 1. Let me pull it up. That's not what you want. So if I go to our, by the way, I don't know if I pointed this out before. It's worth pointing out again. If you go to a web browser version of our Canvas, it's going to look like this. You see the lectures are all there, the slides, the video. I'm pretty sure if you log in on mobile, it doesn't look like this. So just know that this is all there, but you gotta, I don't know what it looks like on mobile. I would assume not this. Anyhow, if you go to Homeworks, 7 years ago, you'll see them there. The lecture slides are there. We pull up Homework 2. It seems very long and tedious, and it is, but it isn't. So if you look at like problems 2 even, that's 9 numbers. You should probably do this one by hand just to get a feel for how, not only, look, I ain't going to be mad if you use a calculator to do it, but I'm saying you should do it by hand for 2 reasons. 1, to make sure you understand the formula. But more importantly, to get a feel for how tedious some of these are. And then you can gain an appreciation for software. So what I thought we would do is we'll start with an example like number 2 or 3, and then we'll kind of work our way down this homework. How's that sound? Does anybody have a question at all before we do any of this? Good, okay. Let's go back to our share. Is anybody sitting in the waiting room? I haven't checked. Nope. Everybody's here. Boys, like the doctor's office. Come on down. So let's have some fun now. So what I'm going to do is I'm just going to generate a list of numbers, and we'll do these. We'll do one computation by hand, and then we'll show you like how to do it in Excel. That's really the way. I mean, Excel. I won't use Excel other than I'll use it because you guys all have access to it. There's much better software, in my opinion, to use. Maybe you guys can teach yourself Python or something. That'll really land you a job. Look at me. I can do Python. And some of you are like, what the hell is Python? It is a snake, but it's also a computer language. All right, so how did we generate data before I went to this sort of this creature before? So the first thing I'm going to do is I'm going to generate some data. So let's say I generate. I'll just run this again. This will be fine. So I run this code. I generated some data. So let's list this out. So what I'm going to do is I'm going to shrink this so I can copy it. It's not going to work the way I want it to. Come on, Steve Jobs. Where are you at when I need you, bro? So that was not ideal. All right, so here's our data. I'm not going to write. I'll just write it in a list of like this. So example. So here I have a list of numbers. I have 4, 2, 6, 7, 9, 4, 6, 1, 5. You all cool with this? You got no choice. So we could do a bunch of stuff. So why don't we? Let's just, again, I didn't ask you to do this on the homework per se, but just show you what we could do. All right. So I'm going to write it in ascending order. So the first thing I'll do is I'll rewrite it. The smallest number I see is a 2. Then I see a 4. Then I see another. Oh, no, I have a 1. Son of a gun. I really wanted to say it. Now it messed up my flow. Smallest number is 1. Then I have a 2. Then I have no 3s, but I do have 2 4s. Then what do I have? A 5. Then I have 2 6s. And then I have a 7 and a 9. Okay, good. So why did I write it in ascending order? Well, now it's pretty easy for me to get things like, what's the median? The median is 5. I know that right away, right? So I'm just kind of going off the top of my mind right here. What I would encourage you to do is think about things like, okay, imagine you're building a puzzle. How do you build a puzzle? You take your box, you empty it, you put the pieces like on the table or the floor. Maybe some of you never built a puzzle, but if you did, then you say, okay, all these pieces look like edges or corners, right? Or this piece is this color, it has this thing, so I'll separate them. And then you lay everything out, you kind of start piecing it together. And then really, if I went over your house and you built a puzzle, I really don't have necessarily the information on how you went about building it. I see the finished project, right? I don't see the strategy that went behind it. So what I'm saying is right now, everybody, you can do this thing different. I'm just kind of looking at this and getting right away what I can get for free from it. Because it's only 9 numbers, so there's not much work, right? So the next thing I know right away is I can get the mid-range. The mid-range, if you remember, is the first plus the last over 2, so that's just 5. So I'm sort of just doing like, I don't want to say brainstorming, but that's really kind of what I'm doing. I'm having all this fun. Does anybody have any questions about those first two things? So you notice that there's 2 4s and 2 6s. So we say that this is bimodal because both 4s and 6s, there's 2 guys that show up twice. So hopefully that makes sense. And again, this is, you can think of this as sort of me just scratch papering it out. You have a question, Katie? It's bimodal because that's a great question because there's 2 doubles. If there were 3 doubles, it would have been, we'd say it's trimodal or multimodal. And really the mode here, the reason we say that is because what are we going to call the mode? Should we call the mode 4 or 6, right? Does that make sense? Again, this is sort of just conventional language. It's not wrong to describe it another way. Now, there are incorrect ways to describe what you see, but I'm saying there's many correct ways to describe what you're seeing. And part of what we want you to look back on at the end of this semester is just that you can tell correct, you could say that this is the correct and logical way to interpret something versus this is not. So that's kind of what we, that makes you a better scientist. It makes you a better citizen. And when I say scientist, I don't just mean chemistry or biology. I mean, if you're a psychologist or if you're in social sciences, if you don't know how to properly analyze numbers, you're really worthless. I mean, I don't mean that in a wrong way, but people analyze numbers all, you hear crap, you hear especially the political nonsense of how people say, well, this is, more people do this and that, and they just skew numbers any which way they want to, and it's just completely illogical, but they do it. It's like these fools that say, well, more people crash in car crashes and get the Roni, so we should stop driving too if we have to wear a mask. This is what the idiots say, right? Like any 2 of them have anything in common. Like the last time I checked, you ain't contagious when you wreck your car. Are you contagious? Hell no, right? But these idiots will say it. Or they'll say, I ain't getting into it, but they say, I love them, I hate that, they say. The point is, we want you to ask questions like that, Kate. We want you to think about how do we interpret things. Now, of course, there's not much to interpret here. I just picked 9 random numbers right now. It's just sort of like an elementary exercise in computing these things. Okay, so what do we want to do now? We want to, let's compute the mean. So the question is, am I computing a population mean or a sample mean? And since there's no context here, I guess it's up to you which you want to use, right? I didn't put these numbers in any context. So since we gave no context to the numbers, we will compute population. So first off, the thing that's most important to note is, let me be even more careful. So since we gave no context to the numbers, we will say this is a population. Now, I could have said it's a sample too, but let's just Suppose it's a population. So that means that mu, the mean is, well, we add them up. What was it? It was 1, what was it? 2, 2, it was 2 and then 4, 4, 5. So it's 1 plus 2 plus 4 plus 4 plus 5 plus 6 plus 6. And then what was the last one? 7 and 9. And this is divided by 9. Of course, there's lots of ways to do this. Probably the easiest way is I'll just go to a basic Kyoto calculator. 1 plus 2 plus 8 plus 12 plus 5 plus 16. Do it quick. So you end up getting, this is 44 divided by 9. And so 44 over 9 is 4.89. Approximately. Does anybody have a question about that? Now, for the sake of an argument, what I'm going to do is I'm going to ask a computer to double check my work. So one way I can do this is, and I'll show you this, let me share this web page with you. So I've never shared this with you before, I don't think, but it's worth checking out. It's called Wolfram Alpha. And it's pretty much like a Google engine for math and science. It's one of the coolest websites there ever existed. You should check it out. If you pay them, they'll show you how to work everything out. So it's real easy to learn from. So let's take the mean of, what was our list? Let's say, I have to put it in parentheses. What was it? It was 1, 2, and then it was 4, 4, 5, and then what was it? 6 and 6, and then 7 and 9. And you'll see that it got the same answer we got. And just for fun, we might even be able to ask it to do like the mode. What's the mode? See, the mode is 4 and 6, right? Like we said. It will also do the median, which is 5, as we said. We cool with that? All right, now, before we do that, now we have to go back and we have to do our variance. Now, once again, we said that our data was population data. I could have easily just said it was sample and done the same stuff. But I'm going to make a point here. So now let's say if this is population, we want our sigma squared. So what is our sigma squared? Our sigma squared is, this is going to look scary. This is 1 minus, let's say 44/9 squared plus 2 minus 44/9 quantity squared. Ugh. Plus, now I have 4 4s, so I have 4 minus 44/9. Or excuse me, I have 2 of these squared, plus 4 minus 44/9. So you're starting to see how completely ugly this gets, right? I mean, I'm running out of room already. Then it's going to be plus 5 minus 44/9 quantity squared. And then, look, I have to kind of break this up. We know this is going to be all over 9, but I'm not done because I still have another piece. Then I have 6 minus 44/9 squared plus, let's put the other 6 here because I'm running out of room. I apologize that this is sloppy. Hopefully you guys can rewrite it and convince yourself of its validness. Now, what I'm going to do is I am going to, I would hope that you verify this on your own, whether it's by a calculator or not. But, you know, for the sake of time, what we should do is we should go back to our calculator. And let's compute the variance and watch what happens here. So what it did is, notice it's very smart. Look what it did. It computed a number and it told us what it was. It said, assuming sample. So this should not be the answer that we get. We want to use population, correct? So when they computed that, they did everything and divided by 8. Right, and here, let me show you. They'll even show you step by step. If you see, they'll say the sample variance is blah, 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 and they'll even show you how to do it if you pay them. But we don't want sample. By the way, there's other websites that can help you with all this. And I never know why people tell you not to use them. Like teachers would say, you can't use that. You got to do it yourself. The old people would say, what if the power goes out? You can't use a calculator. I'm like, huh? The hell planet are you on? Use a calculator. You think like engineers are out there doing stuff by hand? No, you better hope the hell or not. You want a building that you're walking in being designed by 2 numbskulls doing arithmetic by hand? No, you don't. No matter what your 6th grade teacher tells you. And I say that as a math person. Look, you have to verify things by hand when it's efficient and reasonable, but you don't do that, you know. You're not like out there directing flight patterns for airplanes using like all by hand, right? That's ridiculous. Okay, so now let's run it with population variance, which is the one that we used. And you'll see that the answer is 440 over 81. Which is approximately 5.4. Does anybody have a question about this? Comments, concerns? So I just showed you one tool that can help you with this. Now the problem is with using Wolfram, that's not going to help you when you have a lot of data because you don't want to have to type in 30 numbers. It's a lot easier to copy and paste things into Excel. So if you look at the homework, I asked you to go to the internet and research some things. And you might say, well, I don't know how to do that. Well, now's a good time to learn. Right? Now's as good a time as any. Be resourceful. And then plug them into Excel or any other piece of software and compute these things. So I think it's a good time to also point out to point this out. Let's go back to, I'll go to Excel, hopefully. Oh, you're seeing it. You guys seeing Excel at home? Everybody?
No, we're not.
No.
No?
No.
I'll remedy that. Don't you worry, friends. You seeing Excel now? You don't want to see this, but you don't care about it.
Yeah, we see it.
Yeah.
There we go.
You see it.
Now we're cooking with oil. All right, now we got a blank Excel spreadsheet. So let me just show a couple things real quick. And I'm not saying that this is, if you don't know Excel, that now you'll know it, but I'm just want to show you how easy this is to do.
It's supposed
So-
to hit your schedule.
You still see my schedule
Yeah.
right now?
Yeah, we see it.
Oh, I see it now. I see why you're seeing that. Now do you see Excel?
Yeah, it's blank.
All right, yeah, I figured that out. I'm getting to the bottom of this. All right, so let me just show you a couple of things. Let me just type some numbers in. 5, 7, 13, 6, 22, 3, 4. So there's lots of things you can do on Excel that are pretty straightforward. Let me actually, before I do anything, let me zoom in and change my fonts. Everybody see that a little better? Yeah. All right, so pretty much anything I want to do with this stuff, I can just highlight and do it. So for example, if I highlight it and I right click, you're going to say, well, that looks very, very crazy. Well, there's this one thing you could do that's nice right away is you can do what's called a quick analysis. So if I click on this, it starts giving you some very basic things. You can make charts and lines and tables. There's lots of stuff that you can do. Data bars, there's lots of ways to visualize all this stuff. First and foremost, how do you learn different things? You learn by playing. That's what you do. Now you're gonna say, I don't want to play with Excel. Well, all right, that's fine. I can't help you then. You do the bare minimum and that's fine, but you play, you ask questions. All right, so say we wanted to do some of the stuff we did before. So suppose I highlight this and then I could say, okay, I want to know the mean and the mode and the modian. Modian mode. I like that emoji where the head explodes. That's how I feel like right now. Let me stretch my legs. My legs are sore. When you get old, you still try to be in shape and do things like play basketball and lift weights. Your body just don't work. Okay, so we want to put it somewhere. So let's say we're going to call this the mean. And so let's put the mean next door to it. So let me move this over. And so what you can do, once you highlight where you want to put the mean, I'm going to go up here to this F. This is a built-in thing, which means function. So if I click on it, it's going to ask me what I want. And you'll notice it's in alphabetical order, but you can also search by telling it what you want to do. But let's just say I want to do the mean. Well, that's another word for that is average. But you might also say, I'm going to type in mean. And you'll see that mean doesn't exist in that sense. But we can do average. And so if you click on this, it'll ask you what you want to, where you want to go. Well, the easiest way to do it is just to highlight it and then do OK. And you'll see you get 8.57. Now you might say, well, how do I know if, does that correct? Well, let's check it with our data from before. What was our data from before? Our data was what, 1? And then what was it, 2? And then it was what, 4 and 4, and then 5 and 6 and 6, and then it was 7 and 9, I believe, right? So let's put the mean for that here. And then over here we'll do the function and we'll do average. And then we'll highlight this creature. You could type it in manually, but it's easier to highlight. And then voila, I get 4.89, just like we computed by hand. Does that make sense? I mean, this is really not hard to learn. I promise you it's not. And don't get mad at me, he's saying it ain't hard, I'm clueless. It ain't, trust me, this ain't rocket science. Okay, so then let's keep playing the game. So what else did we want to know? We want to know variance. So let's say we'll put the variance down here. Now, we're going to spit the number out here. So let's come up here and then let's type. Nice thing too, when you start using these different built-in functions, it will remember which ones you like to use. Now you'll notice that there's 2 variances. You'll see at the top, this is VARP. This is population, and underneath is VARS, and that's for sample. So we did population, so we click OK. We highlight our values. Bingo, bango, bongo, just like we computed 5.43. Is this so bad? I don't think so, no. And if you get real creative, there's simple ways for you to highlight data, like say on a web page or anywhere, and do the right thing and import it right into Excel. I have a buddy. This is a true story. It's worth pointing out. Maybe it'll encourage you guys to learn this. So he's a big wig at this company. I'll show you all about it. You guys want to see it? Of course you do. So I'll highlight it. This is good. This is called what we call O'Grady Life Lessons. Oh, you guys are still seeing this screen. Are you guys seeing? Is everybody seeing this crap? Wolfram. Is everybody seeing Wolfram?
Yeah, it's on there.
All right, good.
Oh,
So this dude, who's now a friend of mine, I met him. He's older than me, but he's a bigwig at this company. Look, look at his goofy ass picture. But anyhow, I want to point something out to you about him. Is this me logged in? I'm checking Dave out. This is cute. Anyhow, so he's in charge of sales of this big company, Emerson. They sell like energy equipment, like $1 million stuff. They're not selling like cars. They're selling like machines that cost millions and millions of dollars. It's an international company. He got the big house, you know, the big side of town, all that crap. But anyhow, what's interesting about him, he pointed something out. So they had a guy who worked for them who, due to, you know, couple factors, they weren't going to fire him, but they were going to let him, he was older, he was beyond retirement age, and at this point he made too much money. They were like, we got to find someone else to do his job, preferably someone, you know, 40 years younger, that we don't have to pay all this money. And I said, well, okay, what's wrong with that? He's like, well, this is my right-hand man. So Dave's the director of sales. Well, his right-hand man is a guy who's like an expert at Excel. He's their numbers guy. He's the guy that knows how to do all this crazy crap that keeps them making money and not spending as much. And so he fought for 2 years to keep this guy on payroll because of how important he was. And I said, really? That? He's like, this dude can do anything in Excel, and it saves us hours and hours, which turns into, when you save people hours of work, a company that size, that turns into making millions and millions of dollars, right? So it's not like they're working at like Dairy Queen, and if you figure out a quicker way to make an ice cone, you save them, you know, $50 a day. We're talking millions of dollars. And so I always laugh because between that story, and I have another buddy who works at BNY Mellon. He's an account analyst, and he was a history major. And I'm like, so what do you do all day? He's like, it's crazy. He's like, I sit in front of a computer, I have 3 monitors and Excel, and I just play in Excel all day long. I'm like, that's very interesting. It's very interesting. And I was like, is that what everybody does? He's like, yes, in our office, everybody just plays with Excel all day long. So the chances of you spending many years playing with Excel is high. So learn it. Or maybe it's not, I don't know. I just feel like everybody I know who works, they all use Excel constantly. So you should learn it. Or better yet, learn Python. Look at this goofy picture. Can you imagine? Look how he's trying to be funny. We should make it. We'll do this. This is what we'll do. Good old Dave. Why does he have that bald ass head? This will be great. I think we do this. One day I might talk about you. All good though, except for his balding. All right. Anyhow, that's fun. Back to the math. Woo! Does anybody have any questions about that? This kind of stuff. Now, if we're going to be completely real with you guys, let's be as real as we can be. You know, working with 10 random numbers is one thing, but that's not really, you know, you got to be able to do these basics, but imagine real world problems where we have data that we want to analyze. Typically, these data sets are tens, if not hundreds, thousands, millions of numbers. And so what we have to be able to do is figure out how to get those numbers, whether we do an experiment or measure, or like I'm asking you to do on this second homework, go to the internet and look things up. Once you get these numbers, what's your source? Is it a valid source? How do you know that? That's another great question. How do you know the information you're getting is valid? So a big thing that I want you to consider when you start working on these problems, and again, we'll talk about this in detail on Monday. It's not like we're gonna do a lot of these ideas on Monday. You got to figure out how to get your data. So you might say, well, why don't you show us? Well, see, I don't think that's the best way to learn. The best way to learn is for you guys to do stuff. And who knows, maybe you get stuck. Maybe you can't find the top 15 WNBA free throw percentages. I don't know. If you can't, we'll show you how to find it, right? But you got to try that first. And maybe you'll find a quicker way of doing things than maybe I do. So, you know, some of these things that I asked you to do are easy. You can go to Wikipedia and figure out river lengths. They'll probably have a whole page set aside for that, right? NFL payrolls, that's not going to be hard to find. But you got to figure out, where do you find it? Is it valid? How do you make sense of it? So I left these sort of doors open for you guys on the assignment. If you read these, let me go back to it, because maybe I'm not being, I guess you should be seeing this now, I think, right? I don't know. So if we go back to these, if you look at, is everybody seeing the homework on Canvas out there in Zoom land? So if you look at these, I'm not telling you how to get it. I'm telling you to go get it. Well, I guess I am saying use Google, but you don't have to use Google. That's just what I would use. Now you might say, I don't know why you using sports, O'Grady. Well, I'm an equal opportunity. See, I have women's sports and I have men's sports. So what else you want me to do? You want me to get like the Indian cricket team on there or something like that? I'll try to do that. So then we want you to do rivers, and then we want you to look up cities. And again, we want you to sort of, you know, the purpose of this sort of assignment really is to help teach you new things like Excel, if you don't already know them. If you know them, great. It's also to illustrate how we might collect data. And then really the most important thing is how do we analyze it? I gave you a little bit of instructions, but I'm really leaving it up to you. You know, what can you make of it? What do you infer from your data? Can you infer things? And I tried to illustrate that the first day of class. I said, a company offers you a job. There's 5 people in it. The average salary is like $5 million. I mean, can you infer that everybody makes good money in that company? No, you can't. Not just from that. You would need more information. So these exercises in many ways are designed to get your brain moving. Your brain moving. Okay. Anyhow, does anybody have a question? So, okay, great. Well, then I hope you guys literally spend some time on this, because that's where the learning is going to come from if you spend time on this over the week or the next couple days. And then we'll talk about these problems. So bring questions Monday. We'll do examples. I'll show you how I think about these problems, and we'll go from there. All right, any questions before we end? All right, guys, thank you very much. I appreciate it. Hopefully you learned something, and I'll talk to you on Monday. Be safe. Have a good weekend. Stay out of jail.